Okay, everyone, hopefully you can hear me. I'm just going to start the meeting. It looks like everybody's here now. So what I'm going to talk about today is a little bit about Google Play um, and also a little bit about RecyclerView as well. And we'll just play this on the other screen. Okay, this might, yeah, that works a little better. So first of all, I'll talk about RecyclerView, and then we'll go into some detail about APK signing. And I can see a little spelling mistake there, so I'll just fix that up. Got an extra little G in there. Okay, so that's better. So we'll talk about APK signing. So APK signing is one of those things that are normally pretty easy, but if you want to do something a little bit complicated, then sometimes there's so many options, so many different things that you can do with Android Studio, it can be a little bit overwhelming. So we'll have a look at the normal use case, and then have a look at perhaps what happens when you want to sign, say, for example, a Google Maps application. We'll have a look at a little bit of reverse engineering an application, and then some of the things that you can do to mitigate that, because of course you can't really ever stop people. Once you've released your application, you can't really stop people from disassembling it. But there are things that you can do to stop them from getting useful information out of the APK. So the first thing I'd like to talk about is the RecyclerView. It's not really new. It's not like something that has been released very recently. It's been available for a couple of years now, but the basic idea is that this is the new version of the Android list view control. The old Android list view control was very, very slow. And a little bit painful to use. RecyclerView is still a little bit painful to use because there's a lot of code that you need to write to get it going, but hopefully my explanations in the next couple of minutes will help clear up any problems. And I've been marking the first assignment, and amazingly, some of you were able to tackle RecyclerView and work out how it works all by yourselves. And then here I was thinking it was one of the harder things that you can do. I'm sure you probably agree with me, it's a little bit tricky to set up. Okay. So one of the first things that you need to do is to add the actual dependency into Android Studio. And I've got a little chat from the comment, and I'll just see what that is saying. And where's Zoom? Oh, okay, a couple of people saying they wish they hadn't done RecyclerView. Okay, well, fair enough. Okay, so maybe today's session will kind of reinforce your thinking, maybe not. Hopefully this will make it a little easier, because it is quite tricky. So you have to include that extra little Gradle library, otherwise it's not going to work. So you need to have that. There's also an app compatibility library that you can use for older versions of Android. And if you need to use that, you can have a look in the Android documentation site. Okay, so this is the main part of it. And we'll jump into the code in a minute, and we might come back to this diagram, but basically I've tried to get down to the very minimal sort of example. So we've got an activity main, And what we do is we introduce this idea of fragments, where we have a nested layout for a row of data that we programmatically create and set up inside of our code, inside of the actual recycler view. So this picture is a little bit abstract right now, but if we jump into the code, I think it will clear things up a little bit for you. So I'll just bring my IDE across to this other monitor. And of course, the thing that we're actually looking for is this type of setup where you've got your recycler view and we have a list that we can scroll through. And we've got these nice indications for when we get to the top and also the bottom of the screen, just to tell us that, you know, you can't scroll anymore. You can also do things like interact with your list as well and select a specific item and then do something with that. So my list has very, very simple interaction. I just click on something and then I get a little toast pop-up message saying whatever the color it is that I have picked. So we'll jump into the code for that. And I think the best place to start is probably the main layout. So I've just got a fairly bare bones Android Studio project here. And here is my layout. And on my layout, I have a recycler view, and we might just go for the WYSIWYG editor view for now and make the screen a little bit bigger. So you can see here that the parent view, it's just a constraint layout, which is what we've been using all semester. And the child view, or the child widget that I add to my recycler view is, sorry, to my constraint layout is my recycler view. So over here, I've maximized that so it's the full extent of the screen. But of course, because it's a nice constraint layout, I can also resize that, which I think is important to be able to do, because you might have a recycler view and you don't necessarily want to have it take up the entire space. So over here, the recycler view, it's the entire screen, but that's not actually necessary. And you know, if you've got a nice constraint layout as your parent, then you can do that. You can resize your constraint layout so it doesn't take up all of the space in the screen. So we can resize that quite a lot, and we can put it anywhere we like. So we could save that and rerun our emulator, and we'll see that it's also no longer taking up all of the space. Okay, and yeah, you can see here that we've got our little recycler view. So, you know, if you wanted to have a smaller viewport onto this list of data, then you know that's something that you're actually able to do. Of course, all of those rows of data, they all get the same layout. You can see here that if I get to the bottom, it's a bit more obvious now that this is not taking up the full screen, but you can see I get that little indication. Okay, so that's a recycler view with a nested constraint layout. You can, of course, change it. And I'm just going to try and make this the full screen again, where it was before. I think that's a little bit bigger than full screen, but we'll just resize that now. And we'll save that and just rerun it. So we've got that's our layout, right? And then if we look at the actual code behind it, the XML, we can see all of the layout there in detail. So if you wanted to work with that directly, that you could come and edit the XML file. So that's the actual activity main. That our main layout, and I think it's important to note that we're interacting with the recycler view control, the recycler view widget itself. It needs a little ID as well. So that's the layout, and you just, wherever you want to use these recycler views, you just add that widget to the screen like that. And then over here, we've got our other layouts, which is the row layout. And so this is the layout that's going to get applied for each of those different little elements in our recycler view. So all of these different colors, white, red, green, etc., they all have this simple little layout called row layout. And so it's a little bit hard to see here because it's a very simple layout, but you can see here that we have a text view, which is just called text view, and then we've got another one called text view color, and these make up the components of our row. So if we wanted to add extra controls or extra detail to a row of our data in the recycler view, this is where we would have to add that information, that extra detail. And those controls, because we want them to spread out on different screen sizes and things, we're just using a very simple linear layout with a horizontal orientation. And so we can have a quick look at the code, the XML definition as well. And that's useful for getting things like the ID and so on very quickly. Okay, so that's the actual layout files. Over here, we've got our actual code. So this is just our activity, our main activity. And you can see here that we've got some fields in our class, which we use to get references to our main layout file, and also references to our recycler view, and those different, and also access to our data adapter as well. So to make it a bit more clear, we get well, to make it super clear, the first thing that we do in our main activity is set up the layout. We need to do that so we can reference and bind into those recycler view and other widgets. So we get a reference to the recycler view using this line of code here, and casting it like that, that's kind of an old-fashioned way of doing things in Android. I don't think that's really necessary anymore, so I'll just remove that. Then we set up a new layout manager over here that we can use with the recycler view, and then set the layout manager of the recycler view over here. So those two lines, they are important. And then we set up a so-called data adapter, and that's kind of like the meat in the sandwich, really. So this will take our data, which could come from anywhere. It could be some values in a value map, in a values file, in the values resource folder. So you might have some strings that you've defined here that you want to reference, or some other type of data, or it could be data that comes from the database, or from a SQLite database, or it could come from a cloud-based database, or it could come from a remote server, and anywhere you like, really. And then, so the data adapter is then responsible for getting that data and translating the data and massaging it into a format that the recycler view is able to display So that's really where most of our code will actually reside. So we set up the data adapter, give it a reference to our data, which we've defined up here. Our data in this situation is just some names of built-in colors in Android. I think that's just some colors that I've copied and pasted from the SDK documentation. There's a table of different colors. So I chopped those up into strings and made a little Java string array to hold on to those. So that's just to keep the recycler view example relatively simple, because it's already hard enough. So we create the data adapter and then we assign that to our recycler view. So we don't have to do any other coding with our recycler view. We just have to give it this data adapter. And then the data adapter over here does the first thing it does in the constructor is it holds onto a reference to the application context, and it also holds onto a reference to the actual string arrays of all of those color references. So the reason that we've got the application context is so that we can later on, when we set up our views and our on-click listeners, we've got a reference to the parent application context so that we can pop up a toast when we want to. Just so that we can have some kind of simple user interaction. So this, in a lot of situations, you need an application context, but to have a data adapter, you don't actually need one. I only have a application context here because I want to use the toast mechanism. So I need to get a reference to that. So that's why I've passed that in here. Okay, and then there's some important methods. So you've got the on create view holder callback. So this just gets called, right? And what that call does is it allows you to set up a little view that will hold one row of your data, right? And so what we're doing there is we are inflating our layout. So you can do that programmatically using this line of code here. And this is where you need to also use the parent context as well. But it looks like we can get the parent context off this view group parameter that's passed into our code here. So we can get the context off of that as well. But we can't, where we're actually setting up the toast down here, we don't have access to it. So that's why I passed it into my class. So we set up our layout and inflate that from the resources directory for that row layout, right? And then from there, we pass that into our color view holder object. And so that's kind of like a template, I suppose. And it basically just holds on to the object state of those widgets that are involved in that part of the recycler view. So it holds on to a reference and the state of the widgets for one row of data in the recycler view. And so to match up with our view, we've got two text views here. So this is one text view, and then we've got another text view over here. So the description text view is just the textual description here, and the color text view. The color text view could probably have been a different type of widget, but lacking imagination, I decided to use another text view widget, but it probably could be a simpler type of widget. It doesn't need to know how to display text, but That's something that you guys can change if if you want to have a hack around, have a bit of a play around with the code later on. So we set up the state for that. We do some object binding so that we've got references to those widgets in the layout file based on the layout that we've passed into the color view holder. And then we've got some getter methods over here so that, you know, everything is nicely encapsulated. And if we want to get access to these data items inside of our class, then we have to do it through the get methods. And, you know, of course, we should always use data hiding and also encapsulate our data. It's not, it's neither a good practice to have these values here, have these data items with a public scope, because then it makes your code a lot more complicated. Because then everything becomes global, and anytime another part of the code likes, it can set one of these fields, the state of one of these fields, without consulting the getter or the interface, which can cause problems. Can make your code confusing and make everything hard to debug. Okay, so that's the create holder callback. So basically we've got these callback methods where we get given some parameters, right? And then we can use those parameters to inflate our layout and then create a container class that can hold on to the state of our widgets. And so there's a little method, a little comment here just saying, you know, it creates a new view. That's the long story short. And over here, what we're doing, we've got a new method called onBindViewHolder. And I think this is the end of the class. Oh, there's one more method as well. So what onBindViewHolder does is it gets past these color view holder objects, right? And it also gets past a position. And then for each of those position indexes, right, it's able to pull the data out of our data array. So we've got these different colors. So when we index our array with the square brackets, we're going to pull out one of those colors, so red, blue, green, or any of those other colors in color data. So we've got all of those different colors in there. And for that particular position. And so that's something that is handled by the recycler view internally. And the number of items in the recycler view is simply defined by this method here. And you can see that that plugs straight into the length of our color data array. So, you know, we're not going to have any problems with array index out of bounds exceptions being thrown or things like that. Okay, so we're doing a couple of things here in this onBindViewHolder method. It's probably the part where things get complicated, but it's only one method. So we get past a holder object, we also get past a position. So the position is the row in our list. So what happens then is we get a reference, we use our holder object, right? What we do is we get a reference to our layout, and to that we add this little on-click listener, and that on-click listener just makes a toast for and the toast message, right? It's going to be, it relates to the position in our color array. So when we come over here to run our code, you know, if we click on green, we get the little green toast, or if we click on blue, we get the little blue toast. That's the idea. So that's what this little bit of code does, is it handles those click events. And it's not just for the description field, it's also for the actual color text field as well. So clicking over here on the icon, for want of a better word, also pops up that little toast, because the click event, it's set up for the layout, so it handles both of those click events, because it's on the parent object in our layout file. So then again, off of the holder object, again, what we're doing is we're setting up the color description field. So we're just calling the set text method, and then again, we're passing in the actual color based on the position, right? And then over here, we're getting the actual text view that we're going to use to set up the actual background color. And then we're using the color.parseColor method, which takes a string, the stringized name of a color from our array, and uses that to create a color code. So all of those different colors that we've got defined here, Android knows how to convert all of those colors into a little red, green, blue alpha channel color code. And so that's all done over here with this little method here, color.parseColor. Okay, and we've got quite a bit of code repetition here, so it might be a good idea. So, you know, whenever you're coding, you want to strive to make your code as simple as possible, so that, you know, when you come back to look at your code days or weeks or months or even years later, you don't have to think very hard about how your code works. So you want to strive and strive and strive to refactor and make your code as simple as possible. So one thing that you can do here, for example, is that we've got some code repetition, and it's probably a little bit more elegant if we were to extract that out to a variable. And so, you know, I'm a huge well, I'm a big user of the refactor tool. So to get into that, you can just right click on the code that you're interested in. You can go into refactor, and then you can go into extract, and then extract variable. And it'll give you options about which part you extract, which part you replace. I want to replace all 3 occurrences. And what we might just do is we might just call this color, just like that. And then, ooh, that was a bad keyword to use, I think. Oh, I know what the problem is. We might just call this color icon. It wasn't the keyword, it was just the name of the object. Okay, and that's just a little bit too much copy and paste. I've always got to be careful of copy and pasting code. Okay, and so that that probably makes our code a little more elegant, because we don't have to dereference those array variables over and over again for each of those different use cases for how we're doing that. So that is basically how you can set up a recycler view, and I've tried to make it as easy as possible, but it is important to remember that it is quite tricky. So you won't be able to create one just in a couple of minutes. It'll take a little bit of time to understand how everything kind of hangs together. So hopefully what I've talked about now is kind of like ease that process for you a little bit. And does somebody have a question?
Quick question on the topic of refactoring code. When would you recommend we create dedicated functions, for instance? this is on a smaller scale. Let's say you're building a very small app where you know that you're not going to be writing a lot of code. So when does it make sense to just write the function in code inside one activity where you'll only be using it once, and when does it make sense to actually make a dedicated function outside?
Okay, it's a tricky question. I think it depends on a lot of things. It depends how complicated your code is. If your code is pretty simple, um, I I wouldn't create new methods, right? Purely just to make my code easier to read. If it makes sense for code readability to add that extra function, then do it. I think everything should be tailored for developer productivity, and so not just the productivity of yourself, but normally you'll be working with a team, and you want to make it easy for other people to read your code. Of course, if you're a contractor, you probably and you want to keep your contract. What happens is people make the code extremely hard to read so that only they can maintain the code. But that's generally something that I would frown upon. It's not a good thing to do. But that's what some contractors do, is they make stuff intentionally obfuscated, hard to read, so that only they can fix it later on. But and I think another thing, when people first graduate, you'll become a junior developer, and you'll be the junior in the team. I think one mistake people make is that they want to impress, and they think the way to impress is by having huge amounts of really complicated code that nobody can read or understand. But actually, I think that's not the right way. I think now that I've been programming for a fair while, I think the best code that I really appreciate is the simple code, not the code that has a whole lot of custom routines, but just the simple code where it's easy to read. You don't have to spend half an hour looking at it and writing notes about the code to work out how it works. So, when you graduate, try and keep that in mind, I suppose. Try and keep it simple as possible for your own experience, and also for the experience of other people too.
So optimize for simplicity, essentially.
Yeah, exactly. Yeah.
All right. Thank you. That makes sense.
Exactly. Yeah. Okay. So that is Recycler View. And I'll just bring the PowerPoint back on screen, and hopefully that'll make a bit more sense now. So, you've got your view holder. That is one of the cells, one of the rows in our Recycler View. The entire widget is the Recycler View, and then inside of that you've got the nested view holder widgets, and they hold the state for the textual description, and also the background color of our icon as well, with this particular example. And everything is held together with the activity main, as usual, as you would expect. So that's something that you might like to include for your third assignment, is a Recycler View. I believe it's one of the, well, I don't believe, I know it's one of the requirements to get the higher grade in the marking criteria. So if you want to get higher grades potentially, then this is probably something to explore in your third assignment. And there's lots of different use cases for including a Recycler View. Lists, they're ubiquitous. You can use them for anything. So there's Recycler View layout. Here's a little bit more about it, just the steps that you need to do. It's pretty much what I've already talked about. And that's just a little bit more information about what I've just talked about now as well. Right. So the next thing I want to talk about is building an APK. And normally that's relatively easy, although I think some of you have had trouble building an APK that works with Google Maps. But I think it's just that the documentation that Google has for Android is evolving, and sometimes it's a little bit terse. And what I mean by terse is that, you know, it lacks detail. It doesn't have a lot of information. So, you know, if you have problems, probably the best shot is to take a look at Stack Overflow. That's a really good place to start. But so we'll have a look at that particular use case as well. But really making an APK should be pretty easy these days. With the early days of Android, when you had to use Eclipse, you had to use the key tool program manually to sign your program. So it's a little bit more involved, but now you really just use the wizard and it will generate the APK for you. And of course, these days you can also generate an app bundle, but that's a little bit more complicated. And the problem with the app bundle is that you need to upload it to Google Play for it to work. Whereas if you build an APK, you can just copy it over to your device and it will work. Of course, when you copy it over to your device, you have to change the security settings on your phone, your tablet to get it working, because normally your phone is going to be sandboxed so that it's only going to work with APKs that have been uploaded to the Play Store, not uploaded directly to the device. So if you do run your APK directly, you might notice some errors. They're not really errors, they're just warnings. You can just ignore them. It's just the Android security system telling you, hey, you've got a problem. And there seems to be more errors and more warnings that you can get with later versions of Android. So, but basically, you can just ignore them and just don't send alerts about the APK or all that kind of stuff. You can create an unsigned APK. It's not worth it. It's not worthwhile. You need to have a rooted device for that to work, and that's a fairly complicated process. So by default, actually, all of the APKs and all of the debug sessions that we have on the emulators or on an actual device, they actually are all signed. So everything's signed. It's just that when you're debugging, it's signed with the debug key. This is just a little glossary. So you've got things like JKS, that's just a Java key store for storing certificates and things. You've got jars, which is a Java archive. And if you rename the jar file to .zip, then you could play around with it with 7-zip or something to open and extract files from it. So it's just an archive of Java classes and things. Then you've got the V1 and V2 signing. You might as well just pick both of them most of the time, unless you're running really low on space. Both seem to be okay from what I've seen. The version 1 jar signing seemed to be the only choice a few years ago. Now we've got version 2 APK signing. I think it just means that your APK is a little bit better protected compared with older APK files. So you don't need to use an external certificate authority. So you don't need to buy an expensive certificate from people like VeriSign or whoever else. You just need to create your own self-certified certificate. And you need to make sure it's not the debug key associated with your IDE. And you need to have that validity period past the 22nd of October 2033. And the most important thing is not to release your private key. And the key or critical thing here is a lot of the time people store their private key inside of their project folder, which is fine. But what happens is that people use things like source control and they accidentally upload their private key as well. Their Java key store, their JKS file. So probably GitHub is probably listed with the key stores of all sorts of different Android projects, but it's really something that you shouldn't do, because what it means is that other people can sign your application and possibly impersonate you. So you need to protect that and actually not upload it to source control, and don't also publish it on the public internet. It's pretty common sense, but it's easy to just add everything to Git and then upload it to GitHub. So I guess just be careful of that. And yeah, again, if you upload your private key, somebody else can sign your application and then use that to impersonate you, possibly upload a new APK to the Google Play Store, all of that kind of stuff, and perhaps inject malicious payloads into your program and send it to unsuspecting people. And you wouldn't want that. So to actually do this, you just need to go to the build menu in Android Studio and then just go to generate a signed APK. There's a wizard for this, and the next few slides I've got screenshots of everything that you need to do. So you just click on build and then generate signed APK. As I said, these days this is a very easy process. Although if it can get hard when things don't work, as I said earlier. So you can just fill in all of the different details for your key store. You need to have an alias. You need to have a password for your key store as well. You need to fill in all of the details for your certificate as well. You don't actually have to fill in everything here. You can just put in your first and last name. The default validity period of 25 years seems to be pretty good most of the time. That means that after 25 years, your program is no longer going to be, it's not going to, the certificate guarding your program is no longer going to work. So I guess that's something useful to know. So it's this kind of wizard. It's kind of, I always think with wizards, it's always a bit like next, finish. But you do have to look at what you're doing. So make sure you do that. It might be useful not to put not to tick remember passwords. So I'm by no means advocating that you should do that. That was just for my own convenience with this little toy project. And what you want to do is you want to select the build type, which is release. And then you also want to tick the version 1 and version 2 signatures. It's most of the time you won't have too many problems with that. You can have issues if you just select the version 2 signature without the jar signature. Sometimes that causes problems on very old versions of Android. This is the kind of thing that you might experience. That was one where I had an old phone and I only had a version 2 signature. I think these days we probably won't see this as often though. But if you create both a version 1 and version 2 signature, the application will work on both old and new phones, so you should be covered. And then all you need to do is copy the file to your device, open it with the file manager, click install. There's a bunch of prompts and warnings. These screenshots here are for a slightly older version of Android. So it didn't give me as many warnings, but if you with a newer phone, you'll also get a bunch of security warnings and things like that. If your application has different permissions that it needs to use, you'll also have prompts about those, and you'll need to either accept or decline as well. And then at the very end, your application should work on your device outside of the development environment. One thing that you might need to do, often when you debug, you get a debug version of your APK stuck on your phone. So it might be that the install version of your APK file clashes with that. So it's probably a smart idea to just uninstall that before trying to install the APK file on your device directly. Okay, so that was that. And one thing I wanted to note was I saw in the Discord forum, people were saying that they have problems with Google Maps and creating a key, basically. And I just wanted to show you something. So
Most of that was just me taking shortcuts and not realizing that it's not working because I took a shortcut.
Oh, right. Okay. Okay. No, well, that's cool. The thing I wanted to show you is that there's multiple views for your project, right? And I think by default, we have this Android view, which for the most part makes sense. But in some situations, it doesn't make sense. So with our resources folders, we've got these we've got these values that we define, and for Google Maps, we have a Google Maps API.xml file, and there's actually a version for debug and for release. So you can see down here, it's kind of very subtle. If you looked at it really quickly, you wouldn't notice, but in brackets, it's got this Google Maps API, and that's the API key for debug mode only, right? So what I think is happening is people are trying to either put an API key here that was meant for the release version of the application. They're trying to put it here, perhaps. They're just trying to use the release API key here, which is connected to the hash of the released version of the application. So that's one part of the problem. The other part of the problem is that this other file, Google Maps API .xml, this second one doesn't exist, or it's not populated. So what I found was it said this, your key here, when I ran my APK file. So I connected this to my phone and I ran my APK file, and I could see how Google Maps isn't working. And then I could see it's complaining about this, your key here. And I knew that was like the default placeholder value that you get when you first create a Google Maps application. So it turns out that there's another placeholder, right? But that other placeholder is for the release version of this file. So for all of these resources, there can also be another variant of the file in the release folder. So to be able to see those, what you can do is just change modes. And I think the project mode seems to be a bit more, gives you a bit more detail. So if you Android, it kind of wraps everything up into this structure here. But if you change over to projects, it gives you this mode here. And so we've got the source directory there, and we've got a release directory in there. And then inside of that, we've got this extra file. And what I found was that this extra file just had this here, your key here. So I think what's happening is people are probably getting confused and putting their release key against the Google Maps API definition file over here in debug, but they actually really want to put it over here in the release directory, because the variant of this file in the release directory, that's actually what gets bundled up with your release APK file. Another problem that I think people were having is that the fingerprint for their application is different in debug mode. Your SHA-1 hash, that corresponds to the debug package, whereas when you get this little error, it's actually really nice just plugging your device into Android Studio, because you can see that this is in fact the SHA-1 hash that you actually need to generate an API key for this hash and this package. And then so you can go away to Google Maps, the URL, and create a API key for that particular hash and package combination. So your device will actually tell you what you need to do if you plug it into Android Studio. If you don't want to do that though, you can use the key tool program directly. And if you get into the Android cloud website, it will tell you how to do this. If you wade through a couple of hundred different options. So actually finding out how to do this is a little bit tricky. I think it's just that, there's so many different options, but you can get the SHA-1 hash as well using the key tool program. And I just did that using my little terminal window over here. And so you can do this using the key tool program, and you have to provide all of those. So this is just plugging into the key store that you're using to sign your application, right? And so that plugs into all the different values that I had set up here for my application earlier to generate my key store and also use my key store. So you just take those values and then plug them into key tool, and you can then use that to have to put in my password. And then you can use that for getting your hash. But again, it's probably easier to just plug in your device and just create an API key for the hash that your device is telling you that it wants. So I found that easier anyway. So that was just a little, I guess, segue from building an application. But actually building an application is very easy. I haven't given you a demonstration of that yet, but we'll just do it now. So I've set up all of this already. You have to create a key store. You've got screenshots of that as well. You have to set release, and then you can just go finish. And you'll see here, Gradle is building the file. Okay, and then you get this little window here, and it's got this neat little arrow which you can expand, and you can go to locate. And that will allow you to then go ahead and locate that file with Windows Explorer, or I guess the Finder if you're using Mac OS. And then you've got your release APK file. You can rename it if you like, and then you can just drag and drop or copy and paste onto your device and distribute it that way. And this is also, by the way, the same APK that you can also use to upload to the Google Play Store. Okay, so that's how you would generate an application. One thing that is quite important with this is that you can also decompile that built application. I just have to remember where I put all of this. I'm just going to come from my other desktop. Okay. Okay, so we want the app directory, we want the build directory, we want the outputs directory, and we want the APK directory. And so this is a decompilation that I've done of the debug APK, but you can do the same thing to a release APK as well. And what you can actually do is actually just unzip these files. So I won't unzip it again because I don't want to delete my existing project, but okay, what do I want to do? So just to give you an example of that, I will do that again, but we'll put it into a different directory. So just put this into the little temp directory here. And so what you can do is you can just right click on that file, and the APK file, right, it is actually just a zip file. So then you can go into that file and you can see the structure of your compiled resource. So there are some property files, there's your Android manifest file that you can open up and have a look at. You've got some other information that you guys can have a look at in your own time. You've got your resources folder with all of those different resources in there. Things like your layout file. There's more resources in there as well. These are just some of the built-in themes and widgets that are also bundled with your application. And the important thing here is that you've also got these file, or the interesting part here is these files here, classes.dex and also classes2.dex. So what these actually are your programs compiled program code. And so if we're interested in reverse engineering your application, this is what you should actually be looking at. So what you could do, if you were so inclined, is you could run, there's a little program that you can run called classes to, well, dex to jar. And I'll just bring that window over here. So this might be a little bit hard to see, but I'm now in my app debug folder that I've just extracted. And I've got this little program here in my Git directory called Dex Tools. This is something that you guys can download. The latest version is 2.1. And there's a little program called dex2jar, and you just run it. It's a little batch file which calls off to some other programs. And it basically takes that dex file and converts it to a jar file. So mine already exists. It says use -- force to overwrite, and so we can do that. And so what it's doing here is it's taking the Android virtual machine format, which is this dex file, right? And it's converting it back into a Java archive. And so that's turning it into some Java files that a Java virtual machine would be able to run. So it hasn't totally decompiled it yet. It's just taken the Android DEX format and turned it back into Java code. So that's one of the I guess phases of creating an Android program. You can't really see it when you hit build, but it's behind the scenes. It's turned into a Java executable, and then the Java executable is taken and then turned into this DEX file, which is what your Android phone actually executes. So we've just taken it back one step and converted that Android representation, the DEX file, into a Java archive. So the next step is to use another little program called the JD GUI. And this is a nice little program because this is actually what does all of the heavy lifting for us. So if we just close these files, we can just go in and we've got our folder, and there's two files here. So it seems with later versions of Android, you've got some boilerplate code that is bundled with your application now. So this is all of those boilerplate support files that you have to have included with your application. So they're just included here. You can see that it is able to decompile that code. And so that's kind of interesting, but that's actually not our code. So what we actually want to load is classes 2 -dex. And so we just load that up, and that's actually our code. So there's still some more support files in there. But we've also got our actual application code as well. So most of the code that is actually in our APK file is not actually ours. It's actually part of the Android framework and its various compatibility layers. But we can eventually click into our own project. And so we've got the Google Maps example here. You can see that we've got some build config classes, which we normally never actually see. And then we've got our maps activity class, which since you've all just been finishing assignment 2, will probably look kind of familiar to you. And it's interesting, the actual code that it actually generates is actually not too bad. And in some cases might kind of be better than the code that you get from a programmer, perhaps sometimes. But you know, there are some problems, like what is this number? What is that meant to do? So you couldn't take this code and then turn it into an Android project directly. You'd have to do some work to work out what these kind of things were. But you can see that we've got things like our Google Map object, and we are doing the same kind of operations that we were doing in assignment 2. And we've got some permission stuff happening as well. So it's kind of really got most of the code back. Obviously, it's not going to compile 100%, but it wouldn't take a very strong program a little bit of time to turn this into a working program. So, this is just an example of the type of stuff that you can do. So somebody can take your Android APK. They can also take it from the Google Play Store, and they can do this dex2jar on it, and they can convert it back into Java code. So you have to be really careful about what you actually put into your APK file. So what you don't want to do is do things like put usernames and passwords, secrets into your source code, because it's really easy. I've taken a little bit of time to do this just because I wanted to show you how to do it. But, if I wanted to, you can do this in 5 seconds. So do be careful with putting things like usernames and passwords into your code. Probably the better way to do it would be to keep that as a personalized preference that is not embedded into your application code. If it's embedded into your application code, you can guess that your server is going to be taken over pretty quickly, or your cloud account is going to be hijacked very, very quickly if you do that. So do be very, very careful of that. And you can see that the code is really, really readable as well. So that's one thing that you can do. And this is what I've shown you just now. That's really just the, I'm kind of really just skimming the top of it. It's like the tip of the iceberg. There's a whole lot of other stuff that you can do as well to reverse engineer the Android and also Java code. You can get people that are experts in ARM CPU assembly language, and they're able to read the assembly language and make adjustments to your program, all sorts of stuff, all sorts of crazy things. So just come back. Yeah, so we talked about dex2jar. That's what it does, is it reverses things back into a Java archive, and then using that, you can open those files and open them up in a development environment. So yeah, useful thing to do. If you found an APK file on the Google Play Store that you found interesting, and you're interested in how they did the effect, this might be a good way to work out how they did it, how you can reverse engineer that. And so there are ways around this. They don't work 100% because the code is still there, but you can use this thing called minify enabled, which is based on this thing called ProGuard, which is built into Android Studio, so you can turn that on. And what it does is it mangles all of the variable names, all of the method names, all of the method calls. I think it kind of uses a table of like random strings and permutes that with all of your method calls and variables, variable definitions, and all of that kind of stuff. So that'll take your code and obfuscate it like this. But the basic structure of your code will still be there. So people, if they're really determined, they can still work out what you're doing. It'll just slow them down a little bit. There are other products out there that will completely encrypt your application, and you'll have to have some kind of private and public key kind of mechanism built into your application. What happens there is there's like a stub APK loader which extracts the real APK, and so it becomes a lot harder for people to break into your application. But people have worked out that you can trick the stub into extracting things into memory, and then you can use tools to get the APK, the raw APK file out of memory. So again, it's not preventing people, it's just slowing them down. So anything that you put into an APK file, it's going to be out there in the public and anybody can look at it. So you have to be careful about that. And there are, apart from ProGuard, there are some other commercial applications out there that do this kind of thing as well. And they're probably a little bit better, but not by much. You're really just slowing people down. So that's ProGuard. And with your final release, these are just some notes. If you're going to release something onto the Play Store, you really need to test, do heaps of testing, change the orientation of your device, try different devices, try different form factors, try it on things like Android TV, try it on a tablet, try it on a phone, try in portrait, try in landscape mode, try different phones, try older versions of Android. You want to make sure that people have if people don't have a device or a sensor that your application makes use of, you want to make sure that your application can gracefully work without that sensor. So there's some kind of graceful degradation to your application. You want to turn off debugging. This debuggable flag, it's normally set for you now when you use the build menu and the build wizard in Android Studio. This is more for an older version of the project. Of Android SDK. You need to set up all of the different versions of Android that you want to use, and I would make sure that your APK file works on multiple versions of Android. So if you said that the minimum version of Android is 12 or 14 or something, you actually have to test it on that. And don't just test with the emulator, test on a real device, because real devices are different to emulators. You need to make sure that any hardware that you want to use is declared with permissions and features. And if something's optional, make sure your application works without it. The next thing that you might want to do is to set up a Google Play account. The setup screens from a few years, I haven't set up a Google Play account for a long time, or signed up for one, but a few years ago the screen looked like this. And you basically just have to accept the license agreement. You have to pay the $25 one-time registration fee, and then you can start to upload your APK files. You need screenshots of your application. I think you need 2 screenshots of your application and a description, and you need to make sure that your application has a rating for all of the different age groups that can access your application as well. So you need to say whether it's suitable for children or not suitable, and then give your application a self rating. And if it's not rated properly, then people will complain, and you can find that your application is taken down off of the Google Play website. Some other things with Google Play, you need to be really careful that you don't violate the terms of service. So there are things that you can build into your application that violate the terms of service. So, if you have a jigsaw puzzle application that dials some really expensive phone numbers overseas somewhere, that would probably be violating the terms of service, and you'd find that your application's banned from Google Play, and you'd probably also find that your Google Play account would also be banned as well. And it's really hard talking with Google because a lot of their systems are highly automated. So you'd probably find that you're out of luck with trying to negotiate any kind of remediation to that. So you have to be really careful not to violate the terms of service. And they have automated systems for working that out as well, so they can troll over the APKs, do some analysis on them, and work out if they're doing anything potentially malicious, because they don't want, they want to have a nice walled garden for the Play Store. They don't want any potentially malicious applications there. So that is pretty much it from me today. So I've talked about Recycler View, which you'll find useful for your final assignment. And I've also talked about how to make an APK file. Some of the problems that you might have with including API keys with your APK file. And I've also talked about the Play Store and also reverse engineering. So it's pretty much it from me today, guys. I'm going to have a little 10-minute break, and then I'll be back to see if anybody has any questions about the third assignment or anything or any other questions. So I'll be right back.